Right, this video cast is over lesson 4.4, graphing polynomial functions. Before we begin though, I do want to ask you to find your section 3.3 notes. And when you go to section 3.3, how about 3.2? There's going to be that page where we looked at where it said graphing polynomial functions, and we had this whole chart where it says if the degree is odd and if the leading coefficient is positive, then the graph looks like this. And if it was odd and the leading coefficient was negative, then the graph looks like it's going down and then up and then down, or the evens. And so when you need to find this whole chart, I would highly suggest making a copy of this or going back and printing it out again from the course website, because this will become very valuable in this next section. So go ahead and pause the video if you haven't already done so, so that you can find this chart. Alright, so hopefully you found your 3.2 notes somewhere within your notebook folder. If not, you'll just have to do some referencing or copy down that chart again somewhere on this page so that you can take a look back at it. In example A, we are looking at a multiples of our binomials, right? So we got 1/3 times the binomial x minus 5 times the binomial x plus 2 times the binomial x minus 3. And so easy for us, we can easily find the zeros. Again, to find the zeros, all we had to do was just take all of them, set them equal to 0, right? So x minus 5 is equal to 0, x plus 2 is equal to 0, and x minus 3 is equal to 0. So again, x minus 5 is equal to 0, x plus 2 is equal to 0, x minus 3 is equal to 0. So I know that my zeros are going to be x equals to 5, x equals to negative 2, and x equals 3. Well, if you recall from me saying from a previous lesson, zeros are basically where your graph crosses the x-axis, right? So these are your x-intercepts. So at 5, if you wanted to, you can go ahead and graph and plot your point. So at 5, you have your point, and at negative 2, you have your point, and at positive 3, you have your point. Okay. Now my only problem is I have all these binomials, but that doesn't really tell me what my graph looks like. So guess what? We get to FOIL and distribute and multiply through and through and through until we get to our polynomial function. So this is what we did in section 3 when we had all the zeros, right? So except they gave it to us in binomial form, which was one step less that we have to do. But nonetheless, we still have to multiply them all together. So we're going to take 1/3, and I'm going to multiply it. So I'm going to multiply these first two things together. So I got x times x, which is x squared. I got x times 2, well, that's plus 2x. Then I got a negative 5 times x, well, that's a negative 5x. And then I got a negative 5 times 2, and that's minus 10, times x minus 3. Well, I do want to definitely make sure I simplify first before I go any further. So 1/3 times x squared, 2x minus 5x is a negative 3x, minus 10 times x minus 3. Alright, so then we're going to distribute again. So I got the 1/3 on the outside, x squared times x is x cubed, negative 3x times x is negative 3x squared, negative 10 times x is negative 10x, and then I got negative 3x squared. How about squared? And then I get a positive 9x and a positive 30. Okay, so when I simplify again, I get 1/3 x cubed minus 6x squared minus x plus 30. Okay, but I still have that 1/3 out there, so I need to distribute that through, so I really know what's going on. So I get 1/3 x to the third. 1/3 times -6, well, that's going to get us 6/3, which is 2. So -2x squared. We got -1 times 1/3, so minus 1/3 x. And then 1/3 times 30, well, that's 30 over 3, which is plus 10. Okay, so looking at this, I need to know my degree, and I also need to know my leading coefficient. Well, my degree is 3, and my leading coefficient is 1/3. Positive 1/3, right? So positive 1/3 and a degree of 3. Well, that's going to tell me that's an odd graph, right? That's positive. So what we're going to do is we're going to take our graph and it's going to look something like that, right? So basically what I know is, going back to my graph, I know the very end is going to go up, and I know the very tail end on the bottom side is going to go down. Now this chart here, the end behavior thing, that just tells us what we're at. So as our graph approaches negative infinity, as x approaches negative infinity. So starting at 0, 0, if I were to go left, okay, so as I go left, my graph is going negative, right? At least the end result is, right? And as I go positive infinity, my graph is actually going up. So that's a positive infinity, okay? You need to make sure that you kind of understand what that is, but again, going back to that chart would be very helpful. Now, there's a couple more things before we finish this one. So turning points. What does it mean to be a turning point? Well, a turning point is telling us when our graph changes direction. So at some point, it's going to turn around and go the opposite direction, and then it's going to do it again at another point, and so on and so forth. But how do I know that? Well, you take your degree and you subtract 1, okay? As you can see at the very top of our notes, it says n minus 1. Well, I'm going to say d for degree, that way we keep with the same kind of terminology. So I have a degree of 3 minus 1, so that gets me 2. So that means I have 2 turning points. Well, if you look at my rough graph right here, I have 2 turning points, right? It goes up, and then it goes down. So there's 1 turning point. And since it's going down, eventually it's going to go back up, which is another turning point. Alright, but I still don't have a graph. So what am I going to do? Well, we're going to go back to the XY table that we started with in chapter 1. If I do 0, then I know that that's going to be my y-intercept. Well, looking at my equation, my y-intercept is a positive 10. So at 0, 10. So I'm going to go ahead and graph that in there for us. Whoops. And we're going to get that in there. So there's 0.10. Well, that's not too bad. So that's about the middle of the way between those 2 points. So I want to kind of go for middle of 2 points, right? So that was between -2 and +3. Well, my other point is 3 and 5. So what's in between 3 and 5? Well, 4. If you plug in 4, you can either do direct substitution or synthetic substitution. But nonetheless, if you plug in 4, you get -2. So I get 4, -2. Well, there's my other turning point. Well, if I can see it, that should follow where my other graph goes. So all I have to do is just connect the graphs. And there I go. Please make note that your graph goes through these points, but are not sharp points, right? They cannot come to a V like I just did there. They need to kind of be more rounded, okay? And there we have the graph of our first polynomial function. Not too bad, just a little bit of work, some tedious counting and doing some math computations, but all in all, it shouldn't be too bad, right? Because you have all the information that you need, especially when they give you the zeros. Alright, as we look at example B is slightly a little bit different, but they still give us the binomials. All we have to do is, again, set them equal to 0. So I got the x plus 2 squared equal to 0, x plus 4 quantity squared is equal to 0. So I'm going to do that on the side over here. So x plus 2 quantity squared is equal to 0. So if I square root both sides, the square root of 0 is still 0, right? So I get x plus 2 is equal to 0. So x is equal to negative 2. We're going to do the same thing with the x plus 4 squared. So I got x plus 4 quantity squared is equal to 0. So I get x plus 4 is equal to 0. So that means x is equal to negative 4. So there are my 2 points, negative 2 and negative 4. I'm going to go ahead and go to my graph and go ahead and point or plot those points. So there's 2 and there's 4. Okay. Now what I need to do is, again, I need to multiply those together. Well, how are we going to do that? Well, the binomial squared is going to look like 2 times x plus 2 times x plus 2. The x plus 4 quantity squared, that's going to be x plus 4 times x plus 4. Well, we'll go ahead and multiply both things together. So I'm going to take the FOIL, I'm going to FOIL the x plus 2 and x plus 2, and I'm going to get x squared plus 4x plus 4. And on the other one, I'm going to FOIL those together, and I'm going to get x squared plus 8x plus 16. Okay, if you're unsure how to do that, you're going to FOIL. So first, outside, inside, last. Well, now that I have those, I'm going to combine them together. So take each term and multiply it with the next set of terms. So x squared times x squared is x to the 4th. X squared times 8x is plus 8x cubed. And then an x squared times 16, well, that's plus 16x squared. Then if I were to take the 4x, well, 4x times x squared, that's plus 4x squared. 4x times 8x, that's 32x squared. Okay, this first one should be cubed there, sorry, so I kind of wrote that down wrong. And I think I said the wrong thing too, so my mistake there. So you got the 4x times the x squared, that's 4x cubed. 4x times 8x, that's 32x squared. And then I got the 4x times 16. Well, 4x times 16 is 64x. Okay, so kind of ran out of a lot of room there, so I'm going to do it down here. And then I know I'm going to take the last part. Right, so 4x squared plus 32x plus 64. Right? If I were to combine like terms, then I would get, so I'm going to skip down a little bit so I can have some room here. I get 2 times x to the 4th plus 12x cubed plus 52x squared plus 96x plus 64. So there's my long binomial, right? What am I going to use it for? Really nothing. But I need to multiply the 2, so I get 2x to the 4th plus 12x cubed, plus 24x cubed. Can't forget multiplying by that 2, plus 104x squared plus 192x plus 128. So my degree is what? Hopefully you said 4. That's my highest power. And my leading coefficient is 2. So that means I have a positive graph. And because it's even, I know my ends are going to go this way and this way. Okay. So as my graph goes positive infinity, so is negative x. As my graph goes to positive infinity again, so is x values. So going positives and negatives, that's what our graph is going to look like. Well, that means I can safely assume that this is going to be like this, and this is going to be like this. Do I know exact values? We should probably find the values, but because we have such large numbers, I'm guessing that our answers are probably going to be pretty large. Okay, turning point. So again, that was the degree minus 1, which is 4 minus 1, which is 3. So my graph should technically come down, then go up. Well, that's 2. And then go down and back up. So that's a turning point of 1, 2, and 3, right? So I didn't draw that rough draft very well, but we get the idea. Well, that means that turning point has to be somewhere in the middle between -2 and -4. What's my only option? -3. Well, if I did an XY table of -3, I get that the value is 2. So when I plug in 2, I can just go ahead and graph and finish my graph. So there is the graph of my polynomial function for b, where 2 times the quantity x plus 2 quantity squared times x plus 4 quantity squared will look like a nice, very narrow and long w. Alright, hopefully you get all that copied down, and then go ahead and flip to the back side. Alright, as we look at this one, our function is x cubed minus 2x squared minus 5x plus 6. Well, gosh darn it, they don't give us the zeros. But we can figure out the zeros in just a little bit. Meanwhile, let's look at the other stuff. Okay, well, I have a leading coefficient of 1. Right? I have a leading coefficient of 1. And I also have a degree of 3. So let's make sure that we get those down and then kind of determine what kind of graph we have. Well, if I have a leading coefficient of 1 and a degree of 3, then what kind of graph do I have? Well, I have a positive odd graph, right? So that means that my graph will again look something like this. Okay, so what we need to do is find our zeros, right? But we know that as our graph, as x approaches negative infinity, our graph approaches negative infinity, and as x approaches positive infinity, our graph also goes to positive infinity. Now, again, we're still stuck with the dilemma of where's our zeros? How do I know what those are? Well, I would say you would have to graph it to know what that is, but that's our point that we're trying to go for, right? Well, if you look at it, x cubed minus 2x squared, well, I know that the GCF would be x squared, so I get x minus 2 in the parentheses. On the other side, we get negative 5x plus 6. Well, so obviously grouping does not work for this one. So our other only option would be to do my p's over q's. Okay, so my p is equal to 6, which means I get plus minus 1, plus minus 2, plus minus 3, plus minus 6. I know that my leading coefficient was again 1, so I get plus minus 1. So that means my p over q is basically plus minus 1, plus minus 3, 2, I guess I should say in order, plus minus 3, plus minus 6. Now my turning point is my degree minus 1, and so that was the degree of 3 minus 1, so that's equal to 2. So I have 2 turning points. Now because I did the rationals of p over the q, I can easily say, okay, well I gotta find one of my zeros. The only way to do that would be through synthetic division. So let's assume number 1. Let's assume that this gets us to 0, so let's give us a try. So I got 1, negative 2, negative 5, 6, carry down the 1, I get 1. So 1 times 1 is 1, negative 2 plus 1 is negative 1, that's negative 1, that's negative 6, that's negative 6, that's 0. Perfect. So that means this is my remainder of 0, constant of negative 6, the squared, the x is negative 1, and the squared is 1. Okay, so that means I have x squared minus x minus 6 times the quantity x minus 1. How do I get the x minus 1? Well, that's from this, right? This we can say this is x equals 1. So to get it to a binomial, I gotta subtract 1, so x minus 1 is equal to 0. Okay. Now again, what we're gonna do is we're gonna distribute through, so we get x to the third minus x squared minus 6x minus x squared plus x plus 6. But do I need to do that? Probably not, right? What's my goal? We're trying to find the zeros, so I kind of went too far there, and I'm sorry about that. But let's go back. So I need a factors of negative 6 that will get me to a sum of negative 1. Well, the only options that I know that are multiples of 6 is 3 and 2. That will get you to 1. So that means somebody has to be a negative, right? So that's going to be the negative 3. So x minus 3, x plus 2 times x minus 1. So my x values is equal to 3, negative 2, positive 1, right? So that's my 0. So if you want to go back up here and rewrite that, that's okay. If not, that's okay, as long as I can see where you're going with that. Okay, so I got a 3, a negative 2, and a 1. Right, so I know this is going to be a tough delivery of how we're going to get these points, but again, choose what's in the middle. So I'm going to say, well, let's start with negative 1. Alright, well, or positive 1, or negative 1. What should I do? I'm going to do the one that's in the middle. Well, if I did 0, then I could already assume that's going to be 6, right? That's just from an equation. So that's going to be that point there, right? So again, your xy table, if you did 0, you know that's 6, right? You just kind of know. Let's try again. So what if we tried negative 1? Well, negative 1 is going to get me a positive 8. So notice that goes a little bit higher than what we had before, and that's okay. The more points, really, the happier our graph will be. So it's highly suggested that you get a couple more in between your points, just to make sure that they're okay. Okay? And last but not least, you got 2. Well, if you don't plug in 2, you get 4. Excuse me, negative 4. So that would look like this. And I know that the tail ends are going to go up and the bottom ends are going to go down. So I'm going to go ahead and go up, or up, all the way down. And there is my final graph. Alright, well, hopefully you got all of the notes copied there. If not, go back and replay them. Because after that, you need to go ahead and either pick up a review, or you could pick up the review assignment that's up in Google Classroom. So if it's there, I would suggest saying this. The extra credit does get you extra credit points, but I wouldn't worry as much about that than the actual assignment that says chapter 4, 4.4, okay? And so I would go ahead and say work on that. That way you can get there and you can get things done, okay? And you can reference back to this. Okay, so I wish you the best of luck on doing section 4.4 worksheet. Please let me know if you have any questions, and I'll be happy to try to answer them.